This is a brief video on series resistant circuits and why to get the equivalent resistance, which if I were to draw it here, would look like this. You have the same voltage. You have a resistor here, where this resistor to this battery, the circuit from here to here looks the same. So this battery wouldn't know the difference between being here and being here. That's what the meaning of the equivalent resistance is. For a series circuit, I'm going to show you that it's the sum of the resistances in here. And here's how I'm going to show you that. Go back to my original circuit. Clean things up a little bit. I'll put, just to make it as clear, I'll put the V2 on the other side. And this is the, whoops, don't want it so fat. There's the battery voltage. Here's my circuit. Okay, so in this situation here, this is the voltage of the power supply. This is the voltage drop across the first resistor. Anytime you have a resistance, there's going to be a voltage drop across it. So this kind of is like going uphill, going from here to here. This here then, so the current, we take the current, the convention is that it comes out of the plus side. And where it goes into the resistor, that's the plus side of the resistor. And then the other side of the resistor is the negative side, and it goes downhill, so to speak. So it goes down one hill here, and then it goes down the other hill here, starting at the higher point of the hill and then down back to the bottom. And now it's at the same level as it is on this end, because this is a conductor. And everything on a conductor is going to be at the same voltage. No voltage difference across a conductor. Okay, so that's the convention, where each resistor has a voltage drop across it with the plus side facing the battery, facing the plus side of the battery. All right, so one thing we know for sure is that V1 plus V2 has to be equal to V. Okay, that you can't have more voltage drops in the circuit than your power supply, and they all have to add up to be the voltage of your power supply, which is this. The other thing we know is that I1 is equal to I2, is equal to I, which is the current coming out of the battery. The current passing through this resistor, and the current passing through that resistor have to be the same because they're in a series circuit. Great. So what does that mean? That means that, I'll go back to this equation right here. I'll write V, I'll rewrite it here, V1 plus V2. But V is also equal to I1 times R1 plus I2 times R2, but that's, since I's are all the same, I'll just rewrite I1 and I2 as just I. So I could just say it's equal to I times R1 plus R2. I skipped a step there. I should have said I times R1 plus I times R2, and then factored out the I to be I times R1 plus R2. Hopefully you followed that. And then remember, the equivalent resistance is defined to be the voltage of the power supply divided by the current passing through it. Well, let's take that over here. V is equal to I times R1 plus R1 plus R2. So if I divide both sides by capital I get R equivalent, and that R equivalent is simply R1 plus R2. And that's my demonstration that for series circuits, you can find the equivalent resistance by adding the two resistances together. And I can basically use Ohm's law and what we know about circuits to derive that. All right, I hope that this helps you for this week's homework.